Hi, my name is Edwin. S67726. My license number is this. Today I will explain about the Sol-Gel method. So what is the Sol-Gel method? It's a chemical process used to synthesize and fabricate materials, typically metal oxides, through the transition of a colloidal solution which dissolve into a solid network with gel. It involves the hydrolysis and polycondensation of metal oxides or metal salts in a liquid medium, leading to the formation of a gel-like substance. The sol-gel process allows for precise control over the material's composition, structure, and properties, making it a versatile technique or producing nanomaterial and thin film. What is the principle for the solder process? The solder process is a versatile method for producing nanomaterials. It involves the transition of a system from a liquid solid, mostly colloidal, into a solid gel phase. The method is particularly useful for synthesizing metal oxides and involves hydrolysis and polycondensation reactions of precursors, usually metal alkoxides or metal salts. Like example, synthesis of silica nanometer particles, and then the synthesis of titanium dioxide nanoparticles, and then the synthesis of zinc oxide particles. For there are 7 steps in the solder process. First one is preparation of precursor solution. Then is the hydrolysis and condensation. And then third one is the formation of salt, and then following by dilation, and then following by aging, and then there are drying process, and then the last one step is calcination. This diagram shows the soldier process. Like the first step, you put in the precursors and solvents, and then hydrolysis, and then condensation. It becomes from salt is formed gel mass, and then aging and drying. There are 3 steps: is supercritical drying, thermal drying, and freeze drying. It's become 3 types of different gel, and then the last one is calcination. It becomes the final products. For the first step, preparation of precursor solution, metal oxide is dissolved in an alcohol solvent. Water is added to the solution to initiate hydrolysis. The reaction is typically catalyzed by an acid or a base. Second step, hydrolysis and condensation. Hydrolysis, the metal oxides reacts with water to form metal hydroxides. In polydensation process, metal hydroxide contains to form a metal oxide metal network. And then the formation of the salt, the colloidal suspension formed after hydrolysis and polycondensation is called as salt. Gelation, as polycondensation continues, the gel gradually evolves into a gel-like network containing both liquid phase and solid phase. The fifth step is aging. In aging, the gel is aged to follow further polycondensation and growth of the network structure. And then the sixth one is drying. In this process, the gel is dried to remove the solvent, leaving behind a porous solid network. And then the last step is calcination. The dry gel is subject to high temperatures to remove any remaining organic component and to crystallize the material if necessary. And then the types of gel used, aerogels. The dry methods to form aerogel is supercritical drying. So the characteristics of aerogel is extremely low density, high porosity, high surface area, and then application of aerogel is thermal insulation, catalyst support, lightweight structure. The second product is Serogel. This type of gel is made by evaporative drying. The characteristic of gel is higher density than aerogels but lower porosity due to the shrinkage. The application of gel is desiccants, absorbents, and catalysts. For the last one, gel is the cryogel. This one is very special. It's because the drying method is used by the uh, freeze drying, which is lyophilization. And then the characteristic of cryogel is high porosity, low density. It retains original shape, but is good at low temperatures. The application of cryogel is used in biomedical scaffolds, drug delivery, cryogenic insulation. For the advantage of the sol-gel method, first one, because it can produce a wide range of material including oxides, non-oxides, composites, and hybrid material is so that is the very versatility. And then the second one is the control, as it allows precise control over the composition, structure, and morphology of the nanoparticles. And then it's low temperature because it often occurs at relatively low temperature compared to other synthesis methods. And then in this process, it produces high purity material, but it has some disadvantage for the sol-gel method. First one is time consuming because this process is very slow, particularly the aging and drying steps. And then second one is the shrinkage and cracking. The gel is easily to shrink and crack during drying steps. And then it's very complexity because it requires careful control of the reaction condition to achieve desired properties. And then the application of sol-gel derived nanoparticles. First one is catalysis. The metal oxide produced by the sol-gel are used as catalyst or catalyst support. And then it can be used as sensor used in the development of various chemical and biosensor. And then in coating, transparent coatings for optical and protective application. It also used in drug delivery system and for the synthesis of bioactive glass. And then in the electronic aspect, used in the application of thin films for electronic and optoelectronic devices. And then in conclusion, the sol-gel method is a powerful technique for synthesizing nanomaterials with control properties. Is widely used in various fields due to its versatility and ability to produce high purity of materials. This one is the reference that I found for this presentation. That's all. Thank you.